Hello and welcome back to Precalculus. Today we will talk about graphing sine and cosine functions by hand. Trigonometric functions are very important because a lot of applications out there in all sorts of engineering, those functions are, as we have seen, they're periodic, which means they repeat. And because of that, they have a lot of applications and you will be looking at a lot of these graphs. They represent waves of every kind and a whole bunch of other things. So what we see now is the basic graph of sine x. The blue line is not a part of it because it's just my guideline where the top and bottom are for the function. In this case, -1 and 1. And this function is going to have this wave-like property from negative infinity all the way to positive infinity. This function repeats itself, which is called a period. More on that later. But if I put these black lines over here, we can see that in between these three black lines, we have the function repeat itself exactly, right, 2 times the way it is. So it will be repeating itself forever in that way. And then below, we just have some of these basic specs, right? The domain is all real numbers. The range is from -1 to 1. The period is 2 pi, as I mentioned, right? Between, did I have that in the wrong spot earlier? It's supposed to be here. Here to here is a one full oscillation, one full period, and from here to there. I might have had it in the wrong spot. Yeah, I did have it in the wrong spot. This is the full period because you can see that this shape that you see over here, this squiggle, right? This squiggle here is exactly repeated as the red squiggle in the next segment, and it will keep repeating. So the period is 2 pi, meaning that it will repeat every 2 pi the same exact in the same exact way. But it doesn't have to be 2 pi between 0 and 2 pi. You can literally pick any value and then go 2 pi from there, and it will repeat itself. So earlier in my error, I used this one. Well, if I use the maximum point, I can use another maximum point here. And then there will be another maximum point all the way to the right somewhere. And as you can see, the squiggle that you have in between will repeat itself again the same way. So this graph repeats itself no matter where you decide to look at the where you decide to look at these periods. We see the x-intercepts at every pi value, positive or negative pi value, so 0, pi, 2 pi, 3 pi, 5 pi, but also negative pi, -2 pi. X-intercept is where the graph goes through x-axis. And for the y-intercept, we only have one point, which is 0, 0. Now, I did include this notation of plus n pi, just to show that there are infinitely many of these x-intercepts, and that n pi is simply n takes on value of 1 of 0, 1, 2, 3, 4, and so on, and that will represent each one of the intercepts here. So if that n is -1, then we are talking about this intercept here, and that's when n is equal to -1. Well, actually n equals to 1, and then you pick a minus from the formula, but yeah, so there will be a negative pi right there. And you can do the same for min and max, except the formula is a little bit trickier, but think about it. If you have a pi over 2 as x value, where the maximum is, then you just keep adding the period to get to the next maximum, or subtracting the full period to get to the next maximum, because we said that for sines and cosines, for vanilla sines and cosines, the period is 2 pi. Now, can that change? Yeah, we can change it during transformations later on in our second part of this lecture. But now, with this is just sine x graph, it will every 2 pi we are going to have another maximum. So go up 2 pi, go down 2 pi, which is actually left and right. You are going to see another maximum value. So since you are jumping in 2 pi increments, so 2n pi is the way to capture all infinity of these. And the same thing goes for minimum, except minimum is not at pi over 2, it's at 3 pi over 2. And then you again add and subtract period 2 pi to get to value. The y values are 1 and -1, which are the maximum and the minimum value for the trig. So that's it. This function extends infinitely in both directions. You will have infinitely many x-intercepts, infinitely many maximum values, infinitely many minimum values, right? And that stuff. So now let's take a look at the basic cosine, which is our next graph. And as you can see, it looks the same as sine, except it's moved, right? The sine starts here, right? So as you can see, this would be a sine value if the y-axis was on the left black line. Then there would just be a sine. But we have a cosine here, and the cosine starts with its principal period. It starts at 0, 1, and then drops down to pi over 2, then drops further down to a minimum of -1, and then climbs back up at 2 pi to hit the value of 1. Pretty much everything is the same like a sine. It has the same shape, it has the domain and the range. The only, right, everything is what's moved is where the min, max, and the intercepts are. That's what's moved. So the x-intercepts are at every pi over 2, and then plus n pi, because every pi there is a 0, which is the x-intercept, every pi in length. Because we said this last time, between, oh, no, bring back the line. Come on, there we go. Between pi over 2 and 3 pi over 2, there is a pi length in between. And then between negative pi over 2 and positive pi over 2, there is a pi length. So there is always, between any two adjacent pink highlighter here lines, there is always a pi of length in between them. So the period is still 2 pi, x-intercepts are again pi apart, but then the max and min values, right, are going to be 2 pi away from each other. So you can see that, right, the minimum to a minimum is 2 pi of length in a period. So these are the basic graphs, and we remember them. But mainly, and this is the last thing I said last time, you don't need to draw infinitely many. I mean, you can't draw infinitely many of these periods, but you don't need to draw 7 of them, right? 1 is enough, because that 1 will repeat forever to the left and to the right. So we have them as a principal period for fast graphing, so we can get things done quickly. So 0, pi, 2 pi, and again 0 over here in the middle is pi, and at the end is 2 pi. You only draw 0 to 2 pi principal period, and you can use it to solve equations and whatever else we're going to do later. Now, what if we apply, now that we know basic sine and cosine graphs, what if we apply rules from 1.6? Right? Well, you will look at the transformations and you will work out the way to graph the function by hand. So And then you can use technology, obviously, always to check your answer. But having the knowledge of how to graph these functions, right, will make you solve equations later on faster and so on. So, yeah. And they're going to come up in sciences as well. So, yeah, need to know them. Now, what do we have for our 1.6 graphing of sine and cosine? Well, we are going to start by writing y equals a sine bx minus c plus d. You can also have a cosine here, whatever, sine or cosine, it's the same thing. I mean, the same rules apply to both, no matter which one you have. And I'm going to box this. And then I'm going to say the A is the amplitude, which is um, the distance from the middle line to the maximum, or the distance from the middle line to the minimum. Middle line. So that's amplitude, A. B related to the period. Now, what is the relationship? The relationship is period is equal to 2 pi over b. That is very important formula that you will be using to graph all of your functions. So you need to know that formula. C, horizontal shift. Now you have to be careful. Let me just do this. Careful. And then D is the vertical shift. You do not need to be careful here. Right? It's just everything goes 2 units up, everything goes 3 units down. So that one stays completely unchanged from what you learned in 1.6. And the order that I like to present this is dubg. So when you start graphing these functions, start with first utilizing the value d. If d is not present, then you go with a, b, and c. Now I'm going to now graph some of these functions so you guys can see where all of these things come into play. Now also we also have a reflection, right? It's a negative, it's going to flip upside down. So all of those things that you guys learned before, they all stay the same. Now we just have to do it with these wave functions. Y equals 3 sine x plus 1. So let's have just a little bit of this amplitude and the vertical shift. Now remember what I said, dubg, meaning we're going to graph. First, we're going to deal with the amplitude. With the d value, with the +1, and then we're going to deal with amplitude, which is a. All right. So what do we know? This is what we memorized. Come on. What? What is going on? My pen stopped working. There we go. So what do we know? We know that the sine graph starts at 0, ends at 2 pi, and has a maximum of +1 and a minimum of -1. So that's what we know. And I am going to say that this middle line is at 0, right? Call it midline. Right, midline is the actually x-axis now. Well, everything needs to go up 1. So, and I'm just going to draw the basic period. Oh, actually, I have to move everything down because I also see a 3 there. So let's go here. So my original midline is where the x-axis is. But now, because of +1, the midline is going to go up. Let's use blue, I guess. And we're going to say that this is our midline. And that is happening at 1. Now, amplitude is the distance from the midline to the maximum, and then from the midline to the minimum. So I'm going to count 3 units up. 1, 2, 3 units up, that's at 4. And then 1, 2, 3 units down at -2. And I'm going to put my guidelines there. So I have the max line, which is where the maximum is going to be, and the min line, which is the... So now I just need to put my function in it. Since I don't have any shifts left and right and period changes, I can use my standard divisions. So we can use 3 squares for pi over 2, 6 squares for pi, and then 3 pi over 2 and 2 pi. Now, you can't draw off of the black line because that's not your midline now. Everything is shifted up 1 unit. You have to start at the what a new origin is, right? It's no longer 0, 0. Now it's 0, 1 because everything is up. And then pi over 2 for sine will have a maximum. Pi will have a 0. 3 pi over 2 will have a minimum. And 2 pi will have a 0. And you just need to connect the dots. How do I know these dots? Well, I memorized the original graph, right? Pi over 2 has a maximum, pi has a 0, 3 pi over 2 has a minimum, and 2 pi has a 0. Now, I can't draw those points on the black line because everything is shifted up 1 unit. So my good old pi 0 is now actually pi 1. It's just up 1 unit. So we draw the wave through this, and ends right there. And there we go. That is our 3 sine x plus 1. Do I have amplitude of 3? Yeah, I do, because 4 minus 1 is 3. Do I have amplitude of 3 over here? Sure, -2 minus 1 is -3, right? So that's also good. I did not change anything regarding period. I did not shift this left or right because those have to be done directly on x. So that's why I have the basic divisions of 0 pi over 2, pi, 3 pi over 2, and 2 pi. Can you draw another one? Sure, you can draw another one and so on. They will go forever. But this is the principle, right? Let's call it a principle. Squiggle, right? Which is the graph of sine. this graph will continue forever to the left and to the right in the exactly same fashion. The only way to change it is to change the formula. So let's take a look at y equals negative 2 sine of x minus 1. Again, what do we know? Sine starts at the origin, goes up, goes down, ends up back on the x-axis. So that's what the sine does. Now, what is the negative sign going to do? Well, it's just going to flip it upside down, right? So this guy, like that, is going to be negative sine x. And the black one is sine x. So when you put the negative in there, right, we know that from 1.6. I mean, that's negative f of x, right? And negative f of x means the reflection is on the x-axis. So now, if I want to graph this, I will follow exactly the same rules as before. Create those barriers, top and the bottom, with D and A, and then worry about B and C. Now, again, B and C are not a factor in this equation either, because I just have sine x. So we don't have to worry too much about that. Now we want to just worry a little bit about getting these right. So we have our x-axis, we have our y-axis, and I need my -1 midline, because everything is dropping down to the midline level. So this is my midline. And now I need to go 2 units up and 2 units down. Amplitude is always a positive number because amplitude is just the length between a point and the blue line. So lengths are never negative. So yeah, there we have count 2 up, count 2 down, and we have our guidelines. So when you start counting from -1, you go 1 at 0 and then 1 on y. When you count down, you have -2, you have your -3. So that's where the top and the bottom of this is. So now I have my max line, because the maximum will live on it, and I have my minimum line where the minimum is going to live on. Again, nothing shifted left and right, so we can use our standard 3 boxes for pi over 2. Another 3 boxes is pi, and then 3 boxes at 3 pi over 2, and finally 2 pi at the end. So what do I have? Well, the sine will start in the middle line, and now you have to go down first because it's flipped. So we're going to start here, and instead of having a maximum at pi over 2, which is the black line in the upper right corner, we're going to have a minimum, which is the red line. So we're going to go there, and we're going to go there, and we're going to go up, and then we're going to stop in the middle line again. And we just need to draw the function that goes through these. Yeah, it's just terrible. And it's getting worse, so I'm just going to leave it. And there it is. One full period of sine. Sometimes homework asks you to do 2 full periods, right? And, in this case, I just have 1. It will repeat itself forever, to the left and to the right. So I'm not sure if you can if you can see, right, that if you attach the graph to the blue lines and then shift all of the blue lines up, right, it would click nicely on the x-axis. I don't know if that mental experiment is too much, but you can, if you are able to somehow slide this up, it will fit perfectly on the black line. Now, why is it 1 unit down? Because of -1 in the end. So that's a lot, right, for amplitude. Oh, yeah, amplitude, which is, as you can see, amplitude is 2. And then over here, you can also see that amplitude is 2. So that's it for this one. Now let's start playing the game with the period and the left and right shift. All right, so we said that B is the related to the period. Now, I don't care which one of the two formulas, there is the same formula, just algebra flipped. You need to know one of these, and you will be able to compute the period. Now, what is the period doing? Well, remember, it was y equal a sine bx minus c plus d. So as much as it's clear that this d over here is what brings everything up and down, the parenthesis is a little bit more convoluted in this case because you actually have to factor b if you want to do some more advanced math. It's kind of hard to see that. But for our purposes here, we immediately, right, once we see the problem, we immediately extract the b and we compute the new period. Because if that b is anything other than 1, right, the period is going to, if it's not, right, if that number, if b is not 1, then the whole thing is either shrinking or stretching. Now let's see. The best way, obviously, to learn all of this and see all of this is to take a look at the example. So let's say I have 2x. This is it. I don't want any c right now. Let's just deal with the period. So what do we have? Well, according to the formulas above, right, the b is equal to 2. So I can calculate the period as 2 pi over 2, which is pi. Ooh. That's a squish, right? Because the original value for the period, right, is 2 pi, but now for this particular function is pi only. We don't have any shifts up, down, left, right, so we just have the period change. Now, how do we deal with the graph? So we have our x and y coordinate system, and we have the coordinate system, and we know that my amplitude is 1 and nothing is shifted up and down. So I'm just going to put the amplitude, which is at 1 and -1 for this problem. So the period is changed. So the old period was 2 pi, this one is just pi. So what do you do with all of this information now? Well, we know it's going to start at 0, 0. We know that. It's going to start at 0, 0 because the sign starts on the middle line. Now, our middle line never changed. Remember, this is a max line, and this is a min line. Midline now is still the same x-axis, right, before we start messing with the d, right? D is the one that moves the whole thing up or down, and when that happens, right, when that happens, we are going to get this. All right, so now period is pi. That means the entire function has to repeat its full cycle by the time it reaches pi. Okay, so if I have my divisions of pi over 2 and pi, oh, wait, but that's what it has to end. Okay, let me put this line like this because that's where the end is. And now I'm looking at this and I say, wow, I got a box. I just have to fit. I just have to fit the sine squiggle in this box. And obviously we want to do that properly. So we know that sine graph, you should always have the either a sketch of a sine graph or have it in your head. But what we see is that the front, middle, and the end of the graph are all on x-axis, and those are the three dots that you can see. Now, minimum and maximum happens halfway into those intervals. So the maximum has to be halfway here, and the minimum has to be halfway there. And now, even though this graph is going to look the same as every other graph we had today, what is actually different here? Who can tell me? Right? That's the squiggle that we have seen many times. But who can tell me what's different from this graph to any other graph we did? Might be hard to spot.
The length is smaller.
That's it. Beautiful. Yes. It's shorter. The length is shorter. And because the length is shorter, right, it doesn't end up at 2 pi anymore. Now it ends at pi. And we know that the period is pi up there because we had that b, which changed the value of the period. So the original sine graph starts at 0, goes to pi, ends at 2 pi. But the one that we have here, yeah, that one is now is squished, right? This is your 3 pi over 2, and this is your 2 pi over here. So the original graph was supposed to, right, that was the original graph, and you see that this one is just squished to the left. But I'm hoping that you see this box, and that box is created, right? The box is created by figuring out all of the values, and we're going to do more of that now. Let's have a problem that has y equals 3 sine of, and let's go x over 2 minus pi over 6. All right, so now I have amplitude, I have b value, which is 1/2, I have c value, which is pi over 6, and I have a, which is 3. So these are all of the specs that we have to use to graph this. Now calculate period immediately, right? It's going to be 2 pi divided by 1/2, which is 4 pi. So now we actually have a stretch over here. It's double the stretch, right? Because it's the new period is 4 pi. So I already used b to calculate the new period. And I don't have the shifts up and down, but I still have amplitude of 3. So don't draw like this, right? Because now you don't have 3 units to go up, right? Make sure you draw far enough down so that when you draw your lines, you don't hit the writing. So this is our midline, and then 3 units up, 1, 2, 3 units up is going to be my max line, and 3 units down is going to be my min line, minimum line. So the only way to have your midline different than the x-axis is with D, right? D that moves everything either up or down. That's the only way to be off of that line. And now you always write the midline is always what D is. In this case, D is equal to 0, right? Because it's not there. So that's our midline, y equals 0. And yeah, from midline, you measure A. So that's why it's dubk, right? Remember that I had the dubk? Because you graph D first. If you have a value for D, that's your midline. And then you measure amplitude away from the middle line, in this case, 3 each way, which is how I put the blue lines, blue guidelines, max line and the min line. And then you start messing with the B and C. So once I have the midline done, I have the minimum and maximum lines done as well, I can start figuring out where my sine begins. Because it doesn't begin at the origin anymore. Why? Because it's shifted. Now you might say, oh, that's a pi over 6 shift to the right. No, 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 no. It's not. It looks like it is, but it's not, because this is not an x, it's x over 2. And that messes things up. So I'm now going to call this point over here start point. And I'm going to start calling this point here the end point. And the end point is going to be the start point plus the period. So the end point is equal to start point plus period. Now let's calculate the start point. For sine, it's going to be, you take what's in the parentheses and you equal it to 0. Now, why are you doing this? Because you want to find the value on x-axis, right? You want to find a value where that point is. Now, look, if you just have vanilla sine x, then saying x equals 0, well, yeah, we start at the origin, right? X equals 0, right there. And the graph starts. But now, because it's moved, I don't have sine x anymore. I have some mess, this mess. So instead of having x equals 0, you put that mess equal to 0. And now that is going to change into x over 2 equals pi over 6, and then times 2 both sides, x equals pi over 3. There's your start point. Pi over 3 is your start point. And the end point is going to be pi over 3 plus 4 pi. That's your period, 4 pi. So 4 times 3 is 12. So this is pi plus 12 pi over common denominator of 3, which is 13 pi over 3 for the end point. Now that actually gives me my grid up there. So you know the fastest way? Again, if you don't have a square graph paper, I really can't help you. Because if you're doing this on that line paper and you're trying to do these divisions and they're not the same, obviously everything will be crooked and you're pretty much going to learn nothing. So graph paper here is the save. Because look, I'm going to start here and I'm going to call that pi over 3. And all I need to do is to count up to 13, and that's where it ends. This is my start point. So that's pi over 3. And I need to be at 13 pi over 3 to end. Well, how do you get there? Well, just count 1 through 13. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. Done. 13 pi over 3. I don't care what the denominator is. I just went 13 units to the right. It's going to be the same denominator. If I have pi over 6, then it's 13 pi over 6. If I have pi over 4, 13 pi over 4. It doesn't matter what the denominator is, right? We're just going to count 13 spaces, 13 units. And guys, once you extend those lines up and down, you created a box that captures your sine function. Sine function has to start at the start point, has to end at the end point. It has to cross through the middle, right? Because remember, always keep in mind what the sine graph looks like. There is this middle cross, right? So that has to be, right, at 7 pi over 3, because that's exactly the middle between this one. So 2, 3, 4, 5, 6, 7 is right here, 7 pi over 3. And then the middle of each middle, the middle of each half is going to be the maximum and minimum. Now, this is a good time to check if you have a minus sign, because that flips, remember? We don't have the minus sign. So where is the middle? The middle is right there. So this is the middle. And the middle is right here, which is this is the middle. There we go. So we go up, we go down, we go down, we go up, and there's the sign. Now, what are the coordinates of minimum and maximum? Well, remember, that's the x-coordinates, so 2, 3, 4 pi over 3. So the maximum is 4 pi over 3, comma 3. And the minimum is 7, 8, 9, 10 pi over 3 and negative 3. This is so easy. You're just counting numbers. I literally counted 1 to 13 and then find middles. That's all I did. Nothing special. I counted 1 to 13. Now, how do I know it's 1 to 13? Well, first of all, I calculated my start point by setting the parenthesis equal to 0. And then to calculate the end point, I added the period. And that's how I know that I have to count from 1 pi to 13 pi over 3. Yeah, sure. And then when I counted pi over 3 to 13 pi over 3, I found the middle, because the graph has to cross through that middle, and then found the middle of each half for a max and a min. And we're done. That's the principal period. It's actually 4 pi in length, right? And it's also stretched 3 units up. So now I just want to do another cosine graph, looking at some of the stuff that they propose in a book, to be very close to what you guys have, let's say, for your homework. Now, I noticed they don't have a lot of these vertical shifts, like, +1, -3, or something like that, for that D. They don't have those almost at all, which is kind of sad. But, yeah. So, let's see. Problem 48 has a cosine in it. And I'm going to work out the full problem, and then I'll go give you one to try and kind of mute myself for some time so you guys can practice. But let me do this one just to show a cosine situation. There we go. Immediately, A is 1/2, B is 2, C is negative pi. We actually don't need C right? But then, yeah. And let's go with d equals 0. And now we are going to take a look at the way to put this graph together. Now remember, immediately calculate your period, and you can also calculate start and end point and then just put the graph together. So period is equal to 2 pi over b. That is 2 pi over 2. The period is pi. And now we're going to take a look at the start point, SP. 2x plus pi is equal to what? Right? Where does it start? Where it should start at x equals 0, right? Because, again, let me just draw the cosine graph. Yeah, there we go. Cosine graph. This value here is x equals 0. I know it starts on a y value of 1, but that's amplitude to deal with. See, when I say cosine x, to graph a cosine x, then x equals 0, right? Is the where you're going to start drawing this. And then you go to pi over 2, and you go to pi, and you go to 3 pi over 2, right? So when you have the what I call a vanilla graph, you start at x equals 0. That's that line x equals 0. But you will put your point all the way up on top at 1, and maybe it's not at 1, maybe it's at a different value. In our case, obviously, will be a half. So now let's put this to good use. I know that 2x is equal to negative pi, and x is equal to negative pi over 2. This is where I start. So I have to be to the left of the x-axis. And finally, the end point is negative pi over 2 plus the period. Period was pi, which gives me pi over 2 to end the graph. And now I have everything I need for my box. So what do we have? I have, you can literally put them anywhere. It doesn't matter. You will just call them a half. I don't have D, so my midline is the midline. And then I have my max line and the min line equal apart, and that is actually 1/2, right? Negative 1/2. So that's the amplitude up, amplitude down from the midline. Now, I have to go to the left at pi over 2. You can literally pick as far as you want. Let's go now 4, I guess. 1, 2, 3, 4. And call this one negative pi over 2. And then if you went 4 to the left, then you have to go 4 to the right, because the end is also at pi over 2. And that's going to be the box. You see, your start point is the left line, your end point is the right line, and your amplitude away from the midline, up and down, is the up and down of the stream. So, so now what you have? You have a cosine. Just draw the cosine. It starts on the top. It's not flipped, right? So it starts on the top. It ends on the top. In the middle has a minimum. And then the middles of the middles, put the squiggle through. There you go. This is negative pi over 4. That's half. And this is pi over 4, which is a half of a half. Everything is labeled. Do you need these blue lines? No, right? The blue lines can go. There you go. The blue lines can go. We don't need them. Those are just our guidelines to create that box that will house the function. Now, obviously, all of this can be much faster done on a calculator. You just punch in, right? Push enter, and you're done. That's the fastest way to graph, right? I'm going to bring the boxes back, the lines, I mean, because, yeah, why not? I have them in a different color. All right, so I'm going to put a problem for you. I'm going to mute myself, give you guys opportunity to enjoy this little bit on your own. And then maybe I could do one more later, but let's first see what I can. It's fine. I'll do one more cosine. What? Okay, these two are. Okay, try 47 because it does have this 3x plus pi over 2 right there. Okay, so try this on your own for a few minutes, and then I will come back and we'll work it together. All right, let's take a look at the full for the graph. We are going to pick our a, b, c again. Now b is equal to 3, c is equal to negative pi over 2, and d is equal to 0. Do we actually need this d equals 0 and c? In this case, no. In this case, we don't need them. C will be the part of the start point calculation, and d equals 0 means that the middle line is still our x-axis. So let's go and try and figure these things out. Period is always the first thing we calculate. And now, as you can see, it's like 2 pi over 3. Yeah, right? But such is life, right? We'll work with it. It's fine. And we have our start point at 3x plus pi over 2 equal to 0. And the start point is going to be then take away pi over 2 on both sides, right? You're going to have 3x equals to negative pi over 2. Oops, negative pi over 2. And when you divide both sides by 3, you get that x is equal to negative pi over 6 is your start point, which means that for your end point, you need to add the period. Negative pi over 6 plus 2 pi over 3, common denominator of 6. So negative pi plus 4 pi, right? Because you are multiplying by 2. 2 times 2 is, yes, good. And that works out to be negative 3 pi over 6, which actually is negative pi over 2. Now, we are going to use this to do our counting, but on the graph, we're going to put negative pi over 2. Okay, so now we are going to work this out on the graph. Again, I have my middle line. That doesn't change. And we're going to put somewhere the y-axis. And we use the guidelines of amplitude is a half. Again, you can put 2 lines up, 5 lines up, whatever. Let's do 3 lines up. Why not? It doesn't really matter. The scale of x and y axis, it doesn't have to be the same, right? So you can literally put, the important thing is to have them equal amount apart, because amplitude is half this way and amplitude is half this way, right? So they have to be the same separation. But if you want to have 5 lines up and 5 lines down and call it a half, that's okay. It's fine. Now, negative pi over 6, and then you need another 3 pi's over 6. Now, to be honest with you, when I'm... Wait. Something is off. This is a positive value here. No one said anything. Because 4 pi minus 1 pi is positive 3 pi. Yeah. All right, so now I am supposed to graph x equals negative pi over 6 and x equals positive 3 pi over 6. Guys, I'm not looking at pi over 6. I don't care about pi over 6. What I see in my eyes is x equals negative 1 unit, and each unit will be called, in this case, pi over 6. And I see x equals positive 3 units. So I see 1 tick mark on the left and 3 tick marks on the right. That's all I see. I don't care that they're pi over 6 or pi over 12 or pi over 4. I don't care. I just know I need to count to negative 1. Think about, oh, negative 1 apple and 3 apples, right? So pick the amount for 1 tick mark here. So that's my negative pi over 6, and that's my 1 unit to the left. If I picked 2 squares to be 1 tick mark for the left, I need 3 tick marks to the right. So 1, 2, 3 tick marks is where my 3 pi over 6, which is actually pi over 2. We see that there. So I went 1 tick mark to the left and 3 tick marks to the right, and now I just need to complete that box. Boom, boom, and the cosine function is trapped in here. So is it flipped? No, it's not. There's no minus sign. So we start in the corner up, we go to the middle on the bottom, we end on the top, and then middles of the halves, and just fill in the cosine. What are these values? Well, clearly this one is 0, right? Clearly this is pi over 2, comma 1/2 for the top. The other one is negative pi over 6, comma 1/2. And the minimum over here is we have to figure out what these two have as x-coordinates. Well, each tick mark is pi over 6. So this is pi over 6. The next one is 2 pi over 6, which cancels down to pi over 3. Okay. So this point is just, let's call it just pi over 3 right there. And the minimum point is pi over 6, comma negative 1/2. So a lot of students get really worried and hanged on these fractions and starts, I will never be able to graph the pi over 4 and pi over 6 and pi over 12. Guys, you are not shoveling those fractions. You are literally shoveling the tick marks of how many of those fractions you have on a pile. So if I go back to my problem that had 13 of them, right here, I wasn't looking at pi over 3. I was looking at 1 pi over 3, and over here I was looking at 13 pi over 3. That's what I was looking at. So it was so easy for me to just say, I just need 13 tick marks. That's all. Nothing fancy. Nothing fancy. I'm just counting. Just counting. So whatever those divisions are, pi over 4, pi over 6, I don't care. I really don't care. Anything is okay. All right. The last, I hate to call this type of the problem, but the last one is the one where the pi's will be a little bit reshuffled. Let's see. Problem 52, for instance. Y equals 3 cosine of 2 pi x plus 4 pi. This might be, this is actually a typo here, because they should have just say plus 4. I'm going to fix this problem. Just plus 4. So this is problem 52 plus. It has to be a typo in a book, and you will see why. So your amplitude is 3. Your b, which is related to the period, is 2 pi. C is negative 4, and d is 0. Now again, we're not using these in this case because d is 0. That's just middle line is at 0. And again, the original problem had the pi over here, which I deleted because I can guarantee that that's a typo in a problem, writing the problem down. Now let's see why. Look at the period. It's 2 pi divided by 2 pi. You see, the period is 1. The period has no pi in it anymore. So we are now not going to go in increments of pi. We are going to go in increments of what you would call a regular number. because pi is obviously irregular number. Irrational, right? Not irregular, irrational. Anyway, so we have our period p as 1. Now, what is my start point? My start point is 2 pi x plus 4 equal to 0. Oh, but then this is going to be off. Sheesh. Okay, put the pi back in for now. Give me a second. 2 pi x. Oh yeah, you do need the pi there. Because this is negative 4 pi, and now when you divide by 2 pi, yep, not thinking. There we go. It's minus 2. Awesome. So the start point is at minus 2. The end point is minus 2 plus 1, negative 1. Nice. Nice. So, yes, that all sounds good. Okay, good, yes. All right, no, you do need pi. You definitely need pi there. All right. So what do we do here? Well, we make our box. That's what we do. And you put your y-axis somewhere. You put your x-axis. Can't draw this. The ice pack is making the tablet rock, and it's very difficult to draw long, straight lines. All right. 3 units up and down. Okay, 1, 2, 3 units up. 1, 2, 3 units down. And put your guidelines. And now you have your 3 lines. You have your max line, you have your midline, and you have your min line. Do you need to write these? No. No. Do you need the blue lines? No. If you are able to draw this straight without the blue lines, go ahead. So where is my start point? Start point is at negative 2. Okay. Let's go with 4 units. Negative 2. And then the end point is at negative 1. Okay. This is where the whole graph goes. Now you can see the scale, right? 3 squares for 3 units and 4 squared for 1 unit. So the scale is completely off. That it doesn't match. But that's okay. That's okay. You can assign anything you want. The cosine has to start and end on top because there is no minus. Right? If there was a minus 3 up there, then both of these dots would be on the bottom. In the middle, and then the middle of each half. So okay, and if you see a beginning of a fox drawing in here, yes, exactly, that's what it is. So what is the minimum value? It's negative 3 halves for x, negative 3. The maximum value up there is going to be negative 1, 3, negative 2, 3. And these zeros, right, are going to be in... And we're back. Okay. For some reason, it's dropping. So this point here is 5 quarters, 0, and then 6, 7 quarters, 0. There you go. And that's the cosine graph. It will continue doing the same thing forever. We just draw one period. If you need another one, you keep repeating, right? Because the next, you still have it here. So let's go, I guess, green. That's the 2 periods now. Sometimes they ask you to draw 2 periods. That's okay. You can draw 2 periods. You just have to count the same spacings again and do the division for the middle, and that's it. Any questions, concerns regarding graphing the sine and cosine? Because the next lecture is going to graph the rest of them. Secant, cosecant, tangent, and cotangent. That's the next lecture. Anything on sines and cosines? No? Okay, so the things to remember. Dubk, that's gonna be your midline. Then D plus A, max line. D minus A, min line, minimum line, yes. Start point is the argument, which is the stuff in the parenthesis, equal to 0. And then end point is the start point plus period. Oh, and I forgot, you have to calculate your period, which is 2 pi over b. Guys, that's it. These are box boundaries, right? The top, bottom, left, and right. And just be careful the way you count divisions, right? You just count and then divide by 2 to find the middle and so on. So this is for sine and cosine. Now it will change for tangent and cotangent, and you will see that secant and cosecant are absolute joke. When you know sine and cosine, you just have one extra step for secant and cosecant, because secant is 1 over cosine and cosecant is 1 over sine. So their graphs are going to be literally one more step than what you see here. Just one step extra. So don't worry about those. The tangent and cotangent are the ones that we have to be careful with, obviously. All right, let's take a break. When we come back, graphing the other 4.